Hello ladies and gentlemen, we're going to do 9.2 today. We're actually going to start some of our conic sections. So today we're going to talk about parabolas. We've talked about them before, we've graphed them before, but we're going to learn new characteristics and then use that information to help us write equations. So again, we are going to learn a ton of equations and vocabulary words in every section. So you need to be very particular when you take your notes. All right, so let's go back and talk about a generic parabola. Okay. All right, so this particular parabola is going to be situated at the origin. All of them are for the time being. Okay, so we know that this is its vertex. Okay, and we know that this is the axis of symmetry. And we oftentimes call the axis of symmetry an axis. So I may say, find an axis, and so you have to find an equation. For this particular one, it's going to be x is equal to 0. The axis of symmetry is always an equation. The vertex is always an ordered pair. So for this one, it's at the origin. So now I'm going to introduce two new pieces of information. Okay. Inside every parabola, there's a cool point called a focus. Okay. It is a focus, okay? And if you think about a satellite dish, and in the center of that satellite dish, there might be a receiver. And so the receiver can receive a signal coming from someplace else. Sorry, brain and mouth aren't working at the same speed. So what happens with the focus is that information comes in here, and then it might bounce off of our curve and then bounce back out into space. So the focus is actually very unique. We won't talk much about it other than how to find it, but we will talk about the focus. Every parabola has a focus. The focus is always, we don't use that math word a lot, but it's always on the inside of the parabola. Okay? All right, so the focus is always going to be on the inside of the parabola. And we're going to give our focus coordinates of 0, and then that's a p. Sorry, I ran into my other one. So the coordinates of the focus are going to be 0, p, for a parabola going in this direction. The distance then from the focus to the vertex is p. Okay? Outside of, ooh, that's a hideous line. This is going to be a line called a directrix, and again it's just additional information about our parabolas, and this is a really bad drawing, but the distance from the vertex then to the directrix is also p. Okay, so the vertex is right smack in the middle between the focus and the directrix. Okay, and then the equation for the directrix in this case would be y is equal to a negative p, because it goes through the point 0, negative p. Remember that distances are always positive, but this gives me the location. Alrighty, okay. The generic formula that we had in previous chapters would be that this is y is equal to ax to the squared. The a did lots of things. It was our vertical stretch factor. Okay, if a was greater than 1. And then our a was a vertical shrink if our a was less than 1. So meaning that the a, sorry, my bad. Yeah, that's right. Okay, if a is positive, we know that the parabola goes up. And if a is negative, we know that our parabola goes down. So that's kind of the information that we learned in the past. All right. A couple other things about the directrix. It is always perpendicular to the axis of symmetry. Okay, so my directrix is always, again that always word, perpendicular to the axis. Okay, all right. So I think that I've given you all of the information. Now, the difference is we're going to rewrite this equation and we're going to introduce our p. Okay? So the generic form, it's called the general form for a parabola that's pointing up, okay, is going to be x squared is equal to 4py. okay? And that says that p is greater than 0 because p is going to have the same effect on our graph that a did, in that if it's positive it goes up, and if p is negative the graph goes down. All right, this is not a form that we like to see. It kind of hurts our head a little bit. So I'm actually going to rewrite this equation, solving for y. And so I'm going to get y is equal to x squared, and I would have divided both sides by 4p. And I'm going to rewrite this one more time as 1 over 4p, and then times x squared. Okay? So that information, including the 1 over 4p, is what's going to allow me to manage my focus and my directrix. So these are the two formulas that we will use if a parabola is going in the up direction. Okay? All right, so I've rewritten both of those formulas for you. Okay? And I'm going to rewrite, I'm going to kind of condense all of this information for you, and then we'll start doing some examples. All right. So this would be the information that I would give you on an exam. You just have to know what to do with it. Okay? So now let's look at another parabola. Let's look at the parabola in case, I'm going to draw a little squiggle so you know that we're done with that one. Let's look at the parabola that's going down. Okay, so here's my parabola. Again, my vertex is still at the origin. Okay, so this is my x and y axis. Okay. I'll do it in a different color, maybe that will be helpful. I'm going to put my focus inside the curve. It's always inside the curve. And the coordinates of this one are going to be 0, negative p. So this distance from the vertex to the focus is p. Distance is never negative. The negative just shows me whether it's on the negative y-axis or the positive y-axis. If my focus is inside the curve, then my directrix is going to be up here because the directrix is always outside the curve. Okay, there's my directrix, and it's going to go through the point 0, p. So this distance is also p. Okay, and the equation for this one would be y is equal to p. All right, so now let me give you the equations, except I just lost my pen, it's hiding. All right, so my standard form or general form, I'm going to use standard form because I think that's the words that the book uses, is going to be x squared is equal to a negative 4py. And again, that's considered the standard form, and the book will ask you to write your equations in standard form. But I can manage this information, so I call it my working formula. So I'm going to write working form because it allows me to do math a little bit easier. Is going to be y is equal to a negative 1 over 4p x squared. Okay? These two formulas are the same. I just solved for y because this is what we're used to seeing. This information is going to help us find our focus and directrix. Okay? I have two more parabolas to talk about. Okay? The next parabola would be one that is turned sideways. Okay? So it might be this parabola. Okay? Go back to orange. Let's go to pink this time. All right, so now I'm going to park my focus on the inside of the curve. The focus is always on the inside. This is my vertex, and my vertex is at the origin. This distance from the vertex to the focus is p, so therefore the coordinates of my focus this time is p, 0, right? And if my focus is here, then that means my directrix is here. Okay? Because remember that the directrix is always going to be perpendicular to the axis of symmetry. So this distance, I'm kind of running out of room, is also p. Okay? So this equation is going to be x is equal to a negative p because it goes through the point negative p, 0. Right? So let me write the equation. The standard form for this one is going to be y squared is equal to 4px. Okay, and remember p is the distance from the vertex to the focus, and then from the vertex to the directrix. Okay, lots of weird words in this particular chapter. Okay, and then I'm going to write the equation manipulated. I'm going to call it the working form because I don't know what else to call it. And I'm going to rewrite the equation solving for x. So I'm going to get x is equal to 1 over 4p times y squared. All right? Anytime you have an equation where one of the variables is to the first degree and the other is to the second degree, if it starts with an x and the y is squared, then we know that that's a parabola that's turned to the right. All right. Last parabola would be this little guy. He's going to the left, going through the origin. Crappy graph, sorry. There's my origin, so that's my vertex at 0, 0. Okay. I'm going to use orange again. I'm going to park my focus on the inside. That distance is p, so the coordinates for my focus are negative p comma 0. My directrix is going to be out here. Okay, so this is my directrix. Okay. And this distance from the vertex to the directrix is also p, so this is going to be x is equal to p because it goes through the point p comma 0. All right, the standard form for a parabola opening to the left is going to be y squared is equal to a negative 4px, okay? And then the working form, again, I'm solving for x, is going to be x is equal to a negative 1 over 4p y squared, okay? You always want to pay attention to the directions on the problem, but most of the time, they're going to want your equations in the standard form. I just manipulate it because it makes finding p a little bit easier. All right, so since I did my notes out of order, let's do an example now. Okay, so now I'm kind of done showing you the different types of parabolas. So let me write an equation, or do an example for you. Sorry, brain and mouth aren't on the same page. So I want a graph, by hand of course, labeling everything, and I'm going to be given x is equal to a negative 1 over 8 y squared, okay? And then once I've graphed, I want to identify, and I'll show you how I expect you to report your answers, the vertex, the focus, the directrix, E-C-T-R-I-X, really weird word, and the axis. And remember, that's the axis of symmetry. We just say, and the axis, okay? So the first thing that I'm going to do is I am going to draw my little coordinate system, and then I'm going to manage my equation. So this is x is equal to y squared, and there's a negative, so that tells me that the graph is going to be going to the left. So I'm going to put a point there at the vertex, and I'm going to call it 0, 0. And then off on the side, I'm going to list that my vertex is at 0, 0. So for those of you that are taking my assessments, in the column, your graph can go in the big column. In your solutions column, your vertex would be listed like this, okay? All right, so the next thing that I have to do is find my focus. Well, I know that the standard equation for the one that opens to the left is x is equal to, and I'm just going to write 1 over 4p y squared, okay? So notice the similarities between these two equations. So now I can say 1 over 4p is equal to a negative 1 over 8. I chose not to include the negative because I can manage the formula and it will help me. Now what I'm going to do is cross multiply, okay? And so I'm going to get a negative 4p is equal to 8. So p is 8 divided by a negative 4. And so I get p is a negative 2. Okay? All right. So all that does is tell me, the negative tells me that I'm going to the left. It is not a distance. Okay? All right. So if I do that, I'm going to go to a negative 2. I'm going to put a dot, and I'm going to write an F. Okay, lots of things to identify on these graphs. And then over here in my column, I'm going to write negative 2 comma 0 for my focus. Well, remember by definition, if this distance is 2, then the distance to the directrix is also 2. So then my directrix is over here on the right, okay, and it's going to be x is equal to 2 because it crosses the x-axis at 2, 0. Okay, so in my solutions column, I'm going to write directrix, and I'm going to write x is equal to 2. Notice that it's an equation. All right. What's the next thing that I have to do? My axis of symmetry goes right there. It's the x-axis. So my axis is going to be y is equal to 0. Now the next thing that I need to do is I need to be able to put my curve on, and I can't just slop it on paper. I actually have to choose a point and find a good value for my graph, because I don't want my curve to just be kind of slopped out there. So what I'm going to do is I'm going to choose a point on my graph. I'm not going to choose a point that's really big, because then I have a lot of math to do. But I'm going to have, here's my original equation, 1 over 8 y squared. So I'm just going to choose a value for x. So I'm going to let x equal a negative 1. And I'm going to write let so you know I chose it. And I'm going to substitute it into this equation, and I'm going to solve for y. So I'm going to get a negative 1 is a negative 1 over 8 y squared. Multiply both sides by a negative 8, okay, because that kills the fraction by a negative 8, and the negative kills the negative. And so I get y squared is equal to 8, take the square root, and I get y is equal to plus or minus the square root of 8. And I'm going to do a decimal, and it turns out to be 2.83 something, okay? So now I can put that information on my graph, all right? So my point is a negative 1, and then plus or minus 2.83, okay? That's going to help me get a nice accurate curve. So if this is my negative 1, and then I'm going to go up 1, 2, it's almost a 3, and then 1, 2, almost a 3. So negative 1, almost a 3, and negative 1, almost to a negative 3, and there is my semi-beautiful parabola, graphed by hand, showing all work. All right, so that takes care of that one. So let's do another example. I'm going to use all kinds of colors today. All right. Next one is going to say the same directions. So it's going to say graph by hand, and then identify the vertex, focus, directrix, and axis. Okay. So my equation this time is going to be x squared is equal to 2y. Alrighty. So the first thing that I'm going to do is I'm going to rewrite solving for y, because it helps my poor little pea brain. So if I divide both sides by 2, I get y is equal to 1/2 x squared. I know that this is a parabola going up, okay, which is really quite helpful, okay? So then if I go back to my original equation that I gave you in your notes, I know that y is equal to plus or minus 1 over 4p times x squared. And I'm going to use the formula in what I call the working form to help me find p. So these two pieces are equal. So I'm going to do 1 over 4p is equal to 1/2. Then I'm going to cross multiply, and I get 4p is equal to 2, divide both sides by 4, and I get p is 1/2. And that helps me locate everything. All right, so we decided that my parabola is going up because a is positive. Okay, so I'm going to put my vertex at the origin. It will move later, but not for a while in our particular book. Okay, if p is 1/2, if we found that information, that means the distance from the vertex to the focus is 1/2. So I'm going to call that 1/2, and I'm going to put a dot, and I'm going to label it. So I'm over here on the side, I'm going to fill in what I know. My vertex is 0, 0. My focus is going to have coordinates of 0, 1/2. And then that means that my directrix, I'll draw it in a different color. We'll do pink because it's the first pin that I grabbed. So the coordinates, this is 0, negative 1/2. This is y is equal to a negative 1/2. So my directrix is going to be y is equal to a negative 1/2. Notice that I would be putting all of this information in my answer column, and I'm including it on my graph. Yes, it's a bit redundant, but que sera. All right, my axis of symmetry is going to be the y-axis, so it's going to be x is equal to 0. And now I just need to find a point. So I'm going to substitute in, so I'm going to let x equal, let's say 2. Okay, so if I substitute that into my equation, I'm going to substitute it into this one since it's already in terms of y. So I'm going to have y is equal to 1/2 times 2 squared. So that's going to be 1/2 times 4. 4 divided by 2 is 2. So my point is going to be 2, 2. Alrighty? So then if I put that on here, this is 1/2, this is 1/2, 2 would be way up there. Okay, so that's 2. Okay, so then I'm going to have my x is 2. My units aren't necessarily square, but that's okay. Alright, so I'm going to plot this point 2, 2. Ooh, it's way up there. And a negative 2, 2. I'm going to connect the dots. And there's my lovely graph. Okay? Alrighty. We just did that one, cruising right along. Okay, I have one more example for you. I think I answered all the questions. Okay, last example. Okay, it says, write the standard form. Let me scoot my paper up, sorry. Write the standard form of the equation of the parabola with a vertex at 0, 0, and then the given focus or directrix. So I'm actually going to do two problems with the same basic directions. So the first one, you're going to be told that the directrix is going to be y is equal to 2. Now what I recommend doing is graphing what you know, because it helps you to determine which equation you're going to use. So I'll do a different color so it's not too confusing. If my directrix is y is equal to 2, that means that this is my directrix, okay? If this is my directrix, that means that my parabola does something like that. And then that means that my focus is going to be in there, okay? If this distance is 2, then this distance is 2. So I know that P is equal to 2, okay? So then I'm going to use my equation. I have it written in the different forms, so let me look going down. So the standard form says x squared is equal to a negative 4py. Okay, so now all I have to do, switch pins because it's really hard to see, is substitute in the p. So I'm going to get, I'll come over here, x squared is equal to, here's the negative 4. It's negative because the parabola is going down. My p is 2. Substitute in the y. So my final answer is x squared is going to be equal to a negative 8y. Alrighty? And that would be my solution. Okay? Again, the graphs are hugely important. Since we have 4 different parabolas, up and down, right and left, it helps you to write the appropriate equation. Alright, my last example, same directions. This is just the B part. Okay, let me flip my page back. Alright, uh-oh, I lost it. This one is going to tell you something. My notes seem to be a little bit discombobulated. Alrighty, there it is. Sorry. My focus is going to be 0, 3. So again, I really want to use my information to sketch a graph before I start trying to write an equation. Alright, if my focus is at 0, 3, so there's my focus, that tells me that my parabola is going to go up because the focus is always on the inside of the curve. And that means that that distance is p, so p is going to be 3, and that means then that my directrix would be down there, and it would be y is a negative 3. So now all I have to do is write the equation. So the standard form for a parabola that goes up is going to be x squared is equal to 4py. I know p, I can write my equation, so I'm going to have x squared is equal to 4 times 3 times y. So I'm going to get x squared is equal to 12y. And now I have my equation. So it's actually not very difficult. The hardest part is knowing which formula to use. So again, making a quick little sketch. is hugely important. All right, let me give you your problems. Okay. All right, number 1 says graph the equation by hand. Then it says find your standards, the vertex, the focus, I got the hiccups, sorry, the directrix, and the axis. Okay. When you do your graphs, you need to label them very carefully. Different colored pens sometimes are polite, or colored pencils, because it helps you to see everything on your graph. All right, your first equation, x squared is equal to a negative 36y. B, y squared, that's a squared, sorry, is equal to 28x. And C, negative y squared, is 18x. So those are the 3 that you're going to graph by hand. You're going to substitute in a point to get a nice accurate curve. You're not just going to wing it. And then your second problem says write the standard form. Even if you use the working form, your answer needs to be in standard form of the equation of the parabola with the given focus or directrix and a vertex of 0, 0. Later in the chapter, much later in the chapter, we'll start moving things around. And then I have a note that remember, a sketch helps a ton. What do they say? A picture is worth 1,000 words. Alrighty, so problem number A, you're going to be told that the focus is 0, negative 6. And then the second one, you're going to be told that the directrix, that's an x, is going to be x is equal to a negative 2. Alrighty, good luck with your problems, and I will see you tomorrow.